and then I'll make you the host. Okay, Dan, you're the host now. Couple words in Bulgarian. Здравейте, това е поредната сбирка на OWASP, OWASP Sofia Chapter. Ще говори Дан, който в момента е в Щатите. Ще е интересна лекция за как може да направим нашия CI/CD по-добър. Okay, Dan, I won't waste any more time, so here you go. You can share a screen and go on. Yeah.
Very good. Thank you all very much for taking the time, I guess, this evening for y'all, but really appreciate you all taking the time this evening. Today I wanted to talk about some observations that we have from working with organizations trying to both advance their software security programs, where they also have an eye on moving to a DevSecOps type of a culture. And I want to talk about some of the trends that we've seen of things that are very good and positive, but also some anti-patterns that we've seen that we think lead to some negative outcomes if people focus too much on the wrong things. So again, I'm Dan Cornell. I'm as of recently, I'm now the Vice President of Product Strategy at Coalfire. A month and a half ago, I was one of the founders of and the CTO of Denim Group, and Coalfire purchased Denim Group. So my slide template is neither Denim Group nor Coalfire. I apologize for the boring slides. But I'll make the PDF of the slides available to everyone. Yeah, so for an agenda today, I want to talk about, again, some of the things that we've seen, some really exciting stuff from the organizations pushing for DevSecOps, some really cool things that have been published in the industry. But then I want to take a step back and look broadly at what at all of the things that an organization needs to do when they look at their software security assurance program, not just the fun things that can go into a CI/CD pipeline. I want to talk about this concept of doing things very fast, as well as things that have to be done slow, and then using the OWASP's software assurance maturity model as a framework. I want to walk through and look at a comprehensive program to talk about what are the things that it makes sense to automate and that where it's reasonable to expect them to go quickly, but what are the tasks that also it's not reasonable or realistic to expect to be able to automate or to be able to really do in what is a stereotypical DevSecOps fashion. Then I'll talk about, just kind of summarize some conclusions, and then obviously have some time at the end for questions, or if you have questions along the way, please feel free to use the chat, and I will try to answer them along the way if I can. So the first thing, we see some really exciting stuff that is being published from organizations like Etsy, like Netflix, where they're doing really amazing things to secure applications via the DevOps pipeline, right? Really, really exciting stuff. And one of my colleagues was at the DevOps Days Austin a couple of years ago, and looked at a lot of the security checks that they were incorporating in pipelines, and asked them, well, what about testing for authorization issues, right? How do you guys incorporate that? How do you guys handle that? And what they got was what we call the two-shoulder salute of like, well, no, I don't know, right? Like, we don't have an answer of how we're doing authorization checks, in our program, because the program was so focused on the DevOps pipeline. And so that observation that we had, and then in working with a number of organizations, what we recognized was there's a lot of the people are talking about, like, what can we do, the really cool stuff that you can do for security in DevOps pipelines. But we saw in too many situations, organizations were focused only on what could be done in the pipeline, right? And so that's the danger there, is the focus becomes, what can I do in the pipeline? And the pipeline is the entirety of the security measures that we are incorporating. And one organization that we were talking to was even going so far as to say, for their mainframe applications, they wanted to start these multiple deploys per day, right? And we had to work with them and really to tell them, hey, let's take a step back and look at this as a whole, because just because certain organizations are looking at deploying multiple times per day, deploying directly from the pipeline, the entirety of their security program is contained there. That is, that's not necessarily, those techniques are not necessarily appropriate for all groups or all teams, and those, and that's not necessarily, like, doing that for its own sake is not necessarily valuable, right? But when we look at pipelines, what sort of security checks do people put in pipelines? We want to do testing for the application, testing for the infrastructure, hopefully infrastructure is code, testing for the cloud environments. And again, the focus is very much on automation. And we've seen that reinforced if you look at the past couple of years of presentations at OWASP chapters, at the OWASP, the larger conferences. There's a whole lot of focus on DevSecOps and on pipelines. But it's also, I think, important to understand that not everything fits into a pipeline, and that shouldn't necessarily be the lens that you use to look at your at your program as a whole. And that's the danger that we see, is this DevSecOps fundamentalism, right? We need to go fast, everything needs to be automated, and with a real strong focus on what can be put into the pipeline. And I think there's a real danger there of mistaking your pipeline for your program, because the program really, as we'll talk about, is taking a step back, looking broadly, and understanding there are certain activities that can go successfully into a pipeline, but there are other activities that are very important that it's not realistic to put into a pipeline. So what do I mean when I talk about an SSA, or a software security assurance program? I think it's important. There's a video, and this video gets used a lot. So if you've already seen it or seen it referenced before, please bear with me, but I think there is some value in seeing this. And what this video from Simon Sinek talks about is, like, you've got to answer your why before you answer your how, before you answer your what. And if you focus too much on the what and don't understand your why, you're going to get to a place where you have less than ideal outcomes. And so, this why is the reason for starting, right? Like, why are you running a software security assurance program? Like, why is your organization running the program? Then you talk about the how, right? So we know, here's the mandate that we have for running our program. Here are the how is the activities, like what things are we going to do in order to get the security of our applications to a certain state. And then the final question is the what. Like, let's look at the specific implementation, and and some of those may be in a CI/CD pipeline. And the challenge that we see in a lot of organizations is they start with the what, right? What can I put into the CI/CD pipeline, without having answered the how or the why. And again, that leads you to potentially less ideal outcomes. And so what is an SSA program? SSA is an acronym that we use for software security assurance. And it's this whole set of practices and activities that you are using in your organization to reliably create, maintain, and deploy secure software, right? So looking at your program as a whole. Some organizations you talk to, what does your SSA program look like? And they say, we're required to do a pen test for PCI. That's not really a program, or at least not one that's likely to be very effective if the only thing you're doing is an annual pen test, that's not tied to remediation activities or other activities you're thinking. Similarly saying, well, here are the security checks that we stuffed into a CI/CD pipeline. That's also not a program. And so the caution here is, don't let the pipeline become the program. And I don't want to say that shifting left is bad. I love the idea of shifting activities to the left or earlier in the process, so that you have the benefit of seeing the outputs of those activities that you can use to optimize. So shifting left isn't bad, but there is a danger in viewing that as the only as the only goal, or of that shifting left as being a goal in and of itself. There's two major frameworks for SSA programs. There's the OWASP Software Assurance Maturity Model and the Synopsys Building Security in Maturity Model. The OWASP SAM was originally built by Pravir Chandra, from OpenSAM. OWASP has forked that and evolved it a little bit. And the structure of this is as 5 different business functions. For each of those, there are 3 security practices and 2 streams for each. And you can go to owaspsam.org. All these materials, both for OpenSAM and for BSIM, are all freely available. And this is the general structure of the program. We'll look at this in more detail here as we go forward. Also, BSIM, originally from Cigital, now owned by Synopsys for a number of years, and it's built a little bit different. It was based on data that they collected from different participating organizations, and they've evolved that from further data collection. They have 4 domains, 3 practices of each, a total of 119 activities. And again, you can look at BSIM stuff on bsim.com. That's a little bit of the structure there. And so for the purposes of this webinar, we're going to look at OWASP SAM for 2 reasons. One, it is more prescriptive. The BSIM is, again, based on observations of what I consider to be skewed toward very aggressive and comprehensive programs, which is good and bad. I mean, it's good because you see some really cutting edge stuff being done. I would argue that in certain cases, maybe all of those practices aren't going to apply to the average organization. And also, the OWASP SAM is less vendor centric. This is an OWASP discussion, but if you're using BSIM, it's pretty trivial to translate this, what we're talking about here, to map between BSIM and OWASP SAM. One caution, or one thing I would say, is if your organization is just starting out with to start to roll out a software or an application security program, like I would actually recommend against using either OWASP SAM or BSIM to evaluate your program, because if your program is just starting out, you're probably not doing anything, or you're going to get very low marks in most of these areas. And so that, like, spending the time to benchmark where you're at versus other organizations is not necessarily helpful. For organizations just starting out, a better recommendation is, like, understand what is the scope or the mandate for our programming, and understanding the why. Why are we concerned about application security? Let's do some testing of a couple of important applications, and with the vulnerabilities that are identified, and I assure you some vulnerabilities will be identified, let's walk those through to remediation. And based on that, you'll have an understanding of what does it look like to find vulnerabilities, to work with the development teams to get those fixed, and then you can start to proceed from there, right? So if you're just starting out, OWASP, SAM, BSIM, probably not a great place to start. If you're just starting out, our recommendation, based on working with a number of organizations just standing up programs, understand what your scope is, test some applications, and walk some vulnerabilities through to resolution, and that's going to that's probably going to get you practically more benefit than, say, a large high-level benchmarking exercise. So now that we've talked a little bit about software security assurance programs, let's talk about this concept of fast and slow. And so the original idea for this talk, or applying this, came from the book Thinking Fast and Slow by Daniel Kahneman. And so what he looks at is that, they call them System 1 and System 2. Your System 1 is your fast, this very instinctive, emotional decision-making process that humans go through. And System 2, the slow, the deliberative, logical purposes. Very deliberative, logical process of distilling information and making logical decisions. Now, for AppSec purposes, I think an important thing to realize is you want to wherever possible, use tools that are available to you to minimize the emotional reaction, right? You want this fast feedback loop, but you want to take the emotion out of it to the degree possible. And so this book obviously is about human thinking in general, not application security programs in the specific, but the high level concepts are something that I think are very valuable when you look at how they can be applied to SSA programs, and especially in the context that we see with DevSecOps, where there's a tremendous focus on, again, what can go in a pipeline, what can we shift left to do very quickly with automation. Also, as an aside, like System 1 and System 2, those are horrible names, right? Same as like Type 1 and Type 2 errors. Instead of calling things false positives and false negatives, I guess if you're an academic, you have to you have to name you have to name things in complicated ways I don't entirely understand. If you're interested in more of the research that Daniel Kahneman did along with Amos Tversky, the great book by Michael Lewis, Undoing Project, really cool to see, walks through a lot of the research that they did and the relationship between those two researchers and a lot of the work that they've done looking at human psychology and decision making and things like that. So a couple of free book recommendations that come along with today's talk about SSA programs and DevSecOps. So in a culture that is like DevSecOps, it's so focused on fast, right? We want to shift everything left. We want automation. We want this pipeline to, for every software change, I want to know at the end of that, is this new version of the software, is this acceptable to deploy, right? It's, I think, important, again, to take a step back and to understand what are the activities in a world so focused on fast, what are the activities that are critical, but that by their nature are going to go slow? And I've got a blog post that I wrote, looking at, as security teams try to get involved with the, with DevOps teams, right, to include security into DevSecOps. This blog post looks at like what is the what is the power that security teams have, but also what is their responsibility, right? And so that's, I think, some important background information to look at. Like, what are the requirements that we have for security activities that go into CI/CD pipelines? And really, what we've seen in working with organizations is there's three characteristics. Like number one, like to be fast in a DevSecOps standpoint, these results have to be available quickly. Where quickly is a relative term, but is one that you need to understand. What is your time budget for security activities in a pipeline? Any results that you're doing from a security standpoint to be fast, those results have to be high value, right? Both developers and security professionals need to be able to look at these results and say, like, yes, I'm glad that as we're trying to move very quickly, we actually took pause to look at these results, right? And so something, SQL injection, public-facing cross-site scripting, these types of vulnerabilities that are comparatively easy to identify, but also really, going to be very damaging if identified. And you want low, and when I say low, I really mean no false positives, right? Again, so you need to recognize when security gets invited to play in DevOps, you've got a limited time budget that is best if that's explicit. Some organizations we talk to and they're like, no, we have 8 to 12 minutes and that's security's time budget in the pipeline, right? That's what they're limited to. Other organizations where there's more of a mandate for compliance, or risk management may have a larger time budget, but it's important to understand what is your time budget as a security professional involved in this. Again, high value. The developers have to care. They have to look at the results and say, I'm glad that you brought this to my attention. And it's critical not to waste the developer's time. There's no easier way to be kicked out of your CI/CD pipeline than to surface a bunch of false positives that then that the developers then identify. Well, these are false positives. Like, I should not have stopped the pipeline because of these results. So with that concept, understanding what does an SSA program look like, we're going to talk again from the OWASP SAM perspective here, and understanding what does it mean to be fast? Again, available quickly, high value results, and no false positives. So if we look at OWASP SAM, at the highest level, looking at governance, right, and then breaking that down into strategy and metrics, policy and compliance, and education and guidance, right? From a strategy and metrics standpoint, like, you can't automate strategy, right? Like, that strategy is going to go back to the why that your organization has. Like, why, what are you trying to do with your application security program, right? Like, you need to understand what your why is, what your mandate is, what level of risk you're willing to accept, what is your budget, and how are you going about that? Like, that can't be automated. That's the slowest of all slow tasks. But when we look at metrics, you can use CI/CD pipelines to feed portions of your metrics, right? And so that is an area where you can use things like pipelines to do this, detection. Jeff Williams from Contrast talks a lot about sensors, right, and feeding this data up. And so you can use CI/CD pipelines to feed portions of the metrics that you're tracking. And again, when metrics are done well, broadly, it is important to automate those as much as possible, right? Like you can't spend a lot of time calculating metrics. That's going to make those metrics less valuable. Now, when we look at policy and compliance, again, the creation of your policies, that's going to go back to what sort of compliance requirements do you have? What is the risk management posture of your organization? So again, your policy creation is going to be slow, right? That has to be humans discussing, understand the regulatory environment. But you probably can automate some policy checks, right? And those may be implemented in a CI/CD pipeline as pass or fail decisions. But you've got to make a determination, right? You've got to be careful of the limitations of the automation in order to determine whether or not something meets certain policy objectives, right? And we'll talk more about this when we look at security testing in the context of CI/CD pipelines to know what is it reasonable to expect to put into a pipeline and what is not reasonable. When we look at security testing in pipelines, right, the testing that you undertake is going to be, potentially two different types, right? There is going to be synchronous, which means that testing is going to run and it's going to complete within the timeline of that pipeline, or asynchronous, where you might kick off some sort of a testing activity, but where that testing activity is going to run independently and finish probably after the pipeline is finished, right? Because if you want to make a decision, you can only make decisions based on on those synchronous testing activities that are going to fit into whatever that time budget you've established in your pipeline is. And then there's the reporting. How do you want to deal with the results that come out of that? And so that's an important thing to understand, especially when you're setting up testing. Do I anticipate, do I have the time budget to complete this testing so I can use it to feed decision making? Or do I need, is this a longer term process that I'm kicking off where I need to have some sort of an exception handling process where if we identify some sort of serious vulnerabilities, we can come back to that development team and address those, even though that's not self-contained within the pipeline. And again, here we've got links to some external resources where I've talked in more detail about this. Okay, now looking at education and guidance. Now, so instructor-led training is slow, right? Again, by its very nature, it's in person now. Over the past year and a half, it's been also remotely delivered, but where you have a human instructor that is leading developers or security professionals through training, that is by its nature a slow activity. If you look at certain e-learning providers, there's some really interesting things. There's kind of the big, more monolithic e-learning classes. Those are slow, but we're also seeing with certain vendors where they have these kind of like short snippets, very specific education tasking against, here's a specific vulnerability in a specific language or framework, and here's how you detect it, here's how you address it. So there is some really interesting stuff that we've seen with some of the vendors in this space where they are starting to break this training up and make it so that you can target developers very specifically to say, you just introduced a cross-site scripting vulnerability, let's give you a small refresher lesson about cross-site scripting. And so there's some exciting stuff going on there. Also, a topic that I'm really excited about and that we've done a bunch of work with, especially my colleague John Dixon, is in this concept of security champions. So how do you embed security expertise into your development teams? And a very common activity that we see from organizations rolling out these security champions is an important responsibility they have is to help configure this security testing in a CI/CD environment and tune it specific to that application or the applications under their purview. And so one benefit of security champions is they can help make the things that can be fast implemented fast, right? They help to make things faster. Also, again, if you're interested, here's another webinar where we talk about these security champions programs and different templates that organizations use to roll these out. A really exciting area that I've seen, where we've seen organizations get a lot of benefit out of those practices. Okay, now moving on from the strategy and the metrics, looking at design. So how do you design security into your application, right? And so these are the activities where you try to design in security that you'll then verify later on in the process, right? So these are important to, to build this, to build these things in so that you're not chasing at the tail end of the process trying to address these. And so we're going to talk about threat assessment, security requirements, and security architecture. And so from a threat assessment standpoint, in general, understanding your application and their threat profiles, that's it's something that you really can't automate. We have seen some really exciting tooling start to grow up around threat modeling that makes it easier to roll out threat modeling programs at scale across organizations. But the nature of threat modeling is, even with some automation in place, it's going to require a lot of manual work. And so again, there's some really interesting stuff with different groups in the space doing this, but nothing that's going to be as as automatable as you could fit into a CI/CD pipeline. And so threat modeling is going to be a slower process, but as I said, I'm excited to see what some players in the space are doing to allow for more agile and incremental changes. Again, not CI/CD fast, but certainly more agile than traditional threat modeling practices. Now, looking at your security requirements, again, determining your security requirements is largely manual, but we are seeing some new tooling support to say, well, I've got a mobile application. Here is how we're going, here are the requirements that by default we're going to include for these, for this type of application. So again, the requirements development is a slower activity, but we are seeing some tooling support for this. And then validating if these are met. Again, a lot of security requirements have to be validated manually, but there are certain types of activities that you can automate from a verification standpoint, and we'll talk about that when we look kind of at the flip side of the OWASP and looking at the verification. Secure architecture, again, your architecture security requirements, largely manual task, and validating architectural level issues is largely manual, but when you look at cloud architectures and cloud environments, there is some tooling out there that can help let you know if certain policies are being implemented. So there are aspects of this that can be automated. But again, when you look at things like architecture and architecture validation, those aren't things that you can expect to get addressed inside of a CI/CD pipeline. Okay, now, so from an implementation standpoint, let's look at how are we securing the build environment? How are we securing the deployment, and how are we managing defects that come out of the process? And so for secure build, this is really at the core of what we're talking about today, right? Is you want your build to be automated from the beginning to the end. This is what you want to have automated so that it's being done repeatedly every time. Every code change you make, you can run that code change through the exact same process, apply validation to know what is the state of this software that we have built, right? So that's really at the core. And we'll also look at how can you integrate security testing into the build process, right? And so static analysis, dynamic analysis, interactive security testing, as well as the software composition analysis. And one really handy tool, if you're looking at doing software composition analysis, is OWASP's dependency check. That's a really good freely available tool from OWASP that can help if you're not doing software composition analysis, that can help get you started doing that. And again, if you're even considering any of the things that we're talking about in this discussion today, you have to have a repeatable build process, right? If you don't have that, please log off, pick up a Jenkins for Dummy book. You can pick this discussion back up later. But that's again at the core of what we're talking about, is you must have your build process be automated and repeatable. Also, an important concept that has become even more important, or is attracted even more attention recently, is the concept of software bill of materials, right? For software that you're delivering, what is in that software? Show me all the open source components and the versions. And again, there's a great freely available OWASP tool, OWASP dependency track. So not dependency check for software composition analysis, but dependency track for generating and tracking software bill of materials. Again, that's something that we see with the US federal executive order on cybersecurity, has a strong focus on software bill of materials. A lot of the .gov agencies in the US at least are pushing for software bill of materials to be delivered. And there's good and bad in that. I don't want to get too far down in the rabbit hole, but there's that's interesting to, yes, it's valuable to know what is in the software that is being delivered to me. But organizations have to have a plan to actually take action based on that. But again, as we see, I think that is something that as organizations developing software, we're going to see a greater focus on software bill of materials as a concept going forward, for better or worse, or whatever that might end up being. One additional, like when I look at especially cloud native applications, the concept of a software bill of materials for a specific application doesn't work or isn't as valuable as looking architecturally at the entire system. Sorry. So as an external resource that you can take a look at is this webinar, the A's, B's, and 4 C's of testing cloud native applications. So that's another external reference. Please feel free to take a look at that. Now, we look at secure deployment. This is really an extension of, or the other half of that secure build, right? But an area where we see organizations are a little less mature. So obviously very related. You need to build, you need to have a repeatable build process. On the flip side of that, you also want to have a repeatable deployment process. And that's an area where we see organizations not being as mature, but one where you do have the ability to automate with technologies like Puppet, Chef, Terraform, where you have the ability to get this very automated and to be done in a very fast from a DevSecOps standpoint. Now, defect management, right? So as you identify vulnerabilities, how do you drive those through to remediation, right? So portions of this can be done in an automated way where you can make it very fast, right? But it's important to understand that you have to tune the scanners that you're using, otherwise you're going to run into problems, right? And this goes back to what we talked about before. You want to make sure that the results coming out of scans, or at least the scans that may be tied to automated defect creation, those results have to be high value. The developers have to agree, yes, this is serious, we understand them, and you have to have no false positives. Otherwise, automating this is just going to create more challenges, right? And so from a technical standpoint, automating defect creation is usually pretty straightforward. Like all these tools have APIs. You can pipe data from one thing to another, so that the technical challenge, the technical challenges here are not great. In practice, with organizations that look to get to this level, there's a lot that goes into this. Again, you have to have your tooling tuned such that you're generating high value, no false positives. And you have to have confidence, and the developers have to have confidence in the data that you're sending them, right? And also, from an automation standpoint, this is only going to work with the types of vulnerabilities that you can find with automation, typically in CI/CD pipelines. So you're not going to be able to find auth level bugs with automation and automate the creation of defects. Now, so for bundling strategies, right? That's something that is that we've paid a lot of attention to as you look to make this transition from a vulnerability that the security team cares about to a defect or to backlog that the development teams care about. You have to be very careful, right? A one-to-one approach. If you run a scan of an application and find 50 cross-site scripting vulnerabilities, you probably don't want to create 50 tickets in Jira, because you're going to spend more time administering defects than you will be actually fixing issues. So you need to understand, how are we going to bundle these vulnerabilities that are coming out? Vulnerability type is is a popular way that we've found to bundle, because you're saying, well, hey, I found cross-site scripting vulnerabilities. Let's chunk these up in bundles of 10 or 20, because we're going to be using the same encoding libraries to fix these vulnerabilities, or the same code changes to fix these types of things. Again, more mature applications you might bundle by severity. If you've already if you've worked through the backlog of what most scanners are finding, and so the scanners are finding like very few things on new runs of the scanning, maybe you bundle them by severity just to say like, oh, hey, we found 2 new criticals. Well, let's make sure somebody knocks those out very quickly. And again, there may be other approaches. It's going to depend on the maturity of the dev team, where you are in the life cycle of testing that software, the types of results that you're identifying. Now, when we look at this, and we look at the metrics and feedback, right? Like this process, the way that we look at this, or the way that we've found the most success, is that you need to have a separation of duties between the scanner that is identifying vulnerabilities and the developer that is fixing the vulnerabilities, right? So scanners find vulnerabilities, developers make the changes and say that they've fixed the vulnerabilities, and the scanners confirm that the developers were successful in doing this, right? And what that prevents is a situation where you send a lot of results to the developers. They just assume, well, everything's a false positive. We're just going to mark those as fixed. And you don't have something else coming in to validate that. Obviously, this also only applies to vulnerabilities identified by automation, right? But that's important to have that separation of duties where one team or one group or one technology is responsible to find the vulnerabilities, but then they also confirm those. You can't have one party that is fulfilling all of those functions. Also, when we look at metrics, there's all these metrics of like the defect density per kiloline of code and things like that. I mean, those are certainly easy to calculate. I don't know if they're super valuable. One of the things that I do like to track, though, is looking at your mean time to remediation, your average time to fix. And we found this to be a good metric for agile teams or teams that are moving to DevOps, because it's asking the question, like, how fast can you fix vulnerabilities, right? We assume for now, at least, every team is going to be identifying or introducing some vulnerabilities, and that's accepted, right? I mean, like, you can't beat the developers up over this, especially not early on, but it's a question of, hey, developers, as we identify these issues, how agile can you be? How quickly can you address these issues? And you can also then, if you look at data coming from Veracode or from NTT App Security, formerly White Hat, they've got data that they publish that is anonymized from their customer bases, looking at, for industries, for different organization sizes, how quickly on average do they fix those vulnerabilities. So if you're going to optimize on a metric, that's one that we've found that we like to work with organizations on, because it's not, you're not placing blame, but you're saying, hey, once you've been shown that there's a problem, how quickly can you address that? Now, so looking at the verification, right? So we've laid out our mandate. We've set our goals for secure design. We understand the build process and how we're going to address the results of testing that we have. Well, how do we verify that we were actually successful in building the software in a secure manner as we set out for, right? And so we're going to look at architecture assessment, testing for requirements, and the broad concept of security testing. So architecture assessment, again, like, this is something that is typically done manually, right? Like, here's our architecture, here's how the pieces are laid out and how they fit together. In a lot of cases, those things have to be verified. Is this actually the way that the system is working? Do we have the proper controls in place? That said, in cloud environments, there are some testing tools out there that will allow you to check certain architectural policies, right? Hey, if we have a data store like an S3 bucket, that should never be open to the world. I want to make sure that there are authorization checks, an authentication requirement before anything gets stored in this bucket, right? I want to understand, what's allowed to talk to our database servers, what is allowed to access these different Lambda functions, right? And so if you look at a tool like a Scout Suite, has a lot of really good checks for cloud environments that'll identify those types of very common issues, right? So you may have some cloud architecture requirements or policies. You can use a tool like a Scout Suite. There's commercial tools also available that are doing these types of things that can, for a subset of what you are looking at, can identify these types of common misconfiguration types of issues. And so that's really, really handy to automate what you can. And those are the types of things that you can include in something like a CI/CD pipeline. Now, for requirements-driven testing, like in a lot of cases, especially when you look at control verification, this is a manual process, right? Checking things like authentication requirements, authorization rules. There's not a great way to automate those, or in situations where we've seen that type of like requirements-driven testing, you end up writing like your test suite ends up being code, but code that is very specific to testing very specific implementation issues. And so you end up having to maintain that code for testing just like you're maintaining the application. And so that's been a challenge. We haven't seen a lot of great uses of like unit test for things like that. And writing automated tests or unit tests to check for things like cross-site scripting and SQL injection, again, that turns then into code that you also have to maintain. Whereas for testing for things like cross-site scripting, for SQL injection, that type of like directed fuzzing is something that you can automate, right? So your abuse and your business logic testing has to be manual, but as we talk in a minute about the overall security testing, for things that are the coding flaws, like that is where some automation is possible. And so that's really what we look at this security testing discipline. This is really what the discussion comes down to, right? And so the question that we need to answer is, how sufficient is the security testing that we can fit into a CI/CD pipeline? And so when OWASP SAM looks at the security testing practices, they have two different streams. The scalable baseline and the deep understanding. So for OWASP and test, just to take a step back, I've participated in OWASP for 15 or more years, and I think that OWASP has has traditionally had a cultural focus on the strengths and weaknesses of automated testing tools, and I would argue that is due to the presence of a lot of consultants that have participated in OWASP. Versus the scanning vendors, right? Who also have participated. I think, especially early on, OWASP was very driven by consultants that and I am a consultant, so I am, part of the problem or responsible for part of the bias. But OWASP has always had, I think, a valuable, but it's important to know where it comes from, but a focus on the insufficiency of automation to identify the spectrum of vulnerabilities that you need to be concerned about. And you can see that, the outgrowth of that in the testing guide and in ASVS, where they include not just the types of vulnerabilities that are easy to find with automation, but also the limits of automation to identify, authentication, authorization issues, other business logic rules in the application as being an important part of sufficient coverage from a testing standpoint. And that's a concept that we'll touch on a couple more times, is looking from a standpoint of coverage of all the things that I'm concerned about going wrong with this application. What portion can I detect with automation versus what portion can I not detect with automation? And that's just an important thing to understand. So if we look at the way that OWASP SAM looks at testing, security testing, when they look at this secure scalable baseline stream, there's 3 levels of maturity. And at the most basic level is like, hey, we're using an automated tool to scan this code base, or to do directed fuzzing of this web application. That's the most basic, is we've taken a tool and run it. The next level of maturity is to say, okay, now we're going to tune this so that this tool is running in a more optimal way for a specific application. The third level of maturity is then to say, we're going to integrate this into the build process, right? Unfortunately, and again, we're assuming for the purpose of our discussion that organizations are at that third level of maturity, but we see the flip side of that, where a lot of teams will take an automated testing tool and just put it into the build process without any sort of tuning. And that leads to bad outcomes. Again, when we go back and talk about, like, are the results coming out of that testing process in CI/CD, are they important, such that developers would agree, and are they false positive free? I guarantee you, if you just take the default run of basically any application security tool, you're not going to meet those two requirements. And so if you stick that directly into the build process, you're going to have problems, right? You're going to be kicking up a lot of data that no one cares about. You're going to be kicking up false positives. And so, so that is an anti-pattern that we see in a lot of organizations. Again, where the focus is, I have to get this into the CI/CD pipeline or the build process, as opposed to saying, well, let's use the tool, configure the tool, and then once we have the tool tuned such that we're happy with the results, then we can look at getting it into the build process. So again, we see too many organizations do this backwards, and that creates mistrust in a lot of cases between developers and the security teams that are trying to help. Now, when we look at the deep understanding testing stream, this is all manual, right? Manual testing for high-risk components, doing penetration testing. You want to integrate testing into the development process, right? So on regular basis, on regular bases. But it's not something where that type of manual testing fits into something like a pipeline. And we've done some things that I think are really interesting, and I think I have a link to this later in the presentation. Looking at, well, let's take the last time we did penetration testing, let's take a code diff so that we can identify which functionality is new, which functionality has been altered, and let's focus our manual testing in those areas. So I think that there's some cool techniques that you can do around that to help use tooling to minimize the requirement for manual testing. But for that deep understanding testing stream that they talk about in OWASP SAM, that's like a lot of that is just not realistic to automate, because you're looking for the types of vulnerabilities that automation is simply powerless to find. So let's look specifically at testing in CI/CD pipeline, right? And so from a static analysis standpoint, the teams that we've seen have success, especially with like, with tests that are going to run synchronous in a CI/CD pipeline, it's more the open source linting type static analysis tools, because you simply need that speed, right? If you look at the commercial grade, commercial static analysis tools that are doing cross method, cross class data flow, control flow analysis, that's we don't see as much success integrating synchronous testing with SAST into pipelines, right? But it's interesting looking at some of the newer technologies like the SEMGREP and whatnot, where they are more powerful SAST tools, but that are geared toward running inside of a pipeline, right? And so, so what do we see here? If you're going to use static analysis tools, you want to cut down the rules, right? And that helps you to shorten the runtimes. And more importantly, you need to identify what are the rules that are, maybe kicking up interesting results, but also more likely to identify false positives. Those are the rules that you want to take out, right? Because you should understand the static analysis testing that you're doing in your CI/CD pipeline should not necessarily be, or should not be, the entirety of the static analysis testing that you're doing, right? The static analysis testing you're doing in a CI/CD pipeline should be those high value, very high confidence results, right? And then on a per sprint basis or on a regular basis, maybe you're running that commercial grade static analysis tool that has the longer runtime, that is identifying flaws that may be more subtle and require some interpretation and require the some looking at through a potential false positive lens, right? So SAST and CI/CD is going to be different than your SAST as a whole potentially. Same thing with dynamic testing and CI/CD. If you've got concerns about runtimes, that certainly makes sense. Where you also, again, want to cut down the rules that you have. And we've done some work, and I've got a link to this here, where we've looked at, again, looking at code diffs to identify what, when I look at this git commit versus this git commit, what functionality looks like it's new, what functionality looks like it might have been modified. Let's focus our dynamic testing there, because those are the parts of the application, assuming I've done previous runs, those are the parts of the application where I have potentially introduced new security vulnerabilities. And so I've got a link out to a talk looking at some things that we've done in that area. Again, interactive security testing and CI/CD, great, all for it. But IAST typically relies on generated traffic in the application. So how are you going to generate that traffic? You may be using DAST to generate traffic, subject to the limitations we talked about before, or maybe you're using your integration test to generate traffic to make sure that you're exercising the application. Looking at software composition analysis in CI/CD, again, think that's great. One thing to understand is looking at runtime trade-offs versus, what is the velocity? How quickly or how frequently are you including new components into your application? Right, looking at the size of your dev team, like how frequently are they putting new open source components in, and how frequently are new vulnerabilities being identified? And this is an area where we've seen the mechanics of integrating software composition analysis into CI/CD are usually pretty straightforward, but we've also seen situations where that's another thing that can fail as part of that build pipeline. And so, obviously on a regular tempo, you need to be doing this. Is it imperative that you do it in your CI/CD pipeline? Maybe, maybe not. So that's something to understand. Looking at, just because the mechanics of it are easy, is it providing the benefit that we expect it to, or would less frequent runs, provide the same results, but provide you with more control? Now looking at operations, right? So we've got this software deployed. We've got testing that we're doing, what on the tail end of this, how much of the operations can be managed. And so, incident management, when you have incidents, that's hopefully not in your Jenkins pipeline. So there may be automation you can use to detect, again, looking at RASP, other technologies like that. Does it look like someone is misusing or attempting to misuse our application? So you can use automation for detection. I've seen some incident response, playbook automation technologies as well on the flip side of that. So there's some automation that can come with that. But incident management, again, is typically automation supported, not wholly automated. One valuable thing to look at is this is a resource from my colleague John Dixon, where he talks about how is the typical logging that developers put into applications? How does that help security professionals, or how is it insufficient? And again, what he's identified, and John's background is not as a developer. My background is as a developer. John's background is as a more of a security professional. And so he looked at the types of logs that he would see from development teams. And again, this talks about what additional information do security professionals need on top of what developers typically log in order to support these types of incident response activities, right? And looking at how developers are typically trying to identify, at this instant in time, what is the state of the application, so I can identify a bug, as opposed to security professionals saying, over time, how has this application been exercised, so that I can look for more broad patterns of potential misuse. So worth taking a look at that video as well. Environment management, and I can't remember. I wish I knew who to credit this with, but it's this concept of servers should be cattle, not pets, right? When I first graduated from university, I was running a company where we did custom software development, and we also managed a number of servers. And we named all of the, each server was named after a different biological agent, which in the time of COVID, maybe that was, maybe we shouldn't have done that. But, also, I'd come out of in university, I think they named all the servers after planets and whatnot. And in the intervening 20 years since I got out of university, right, we've shifted from servers being these very special things that had personalities to being just things that get spun up in the cloud, right? And so your servers shouldn't be pets where they're all individually named. Those should be cattle, right, where they're treated one equal to another, just serving whatever purpose they have. And again, looking at what you've done, hopefully prior to this for secure deployment, hopefully this configuration is all done in an automated way, set up via Chef, Puppet, Terraform, those types of technologies, potentially checking changes or checking the status on the other end using a tool like Scout Suite. And then when you look at the patching and updating stream, again, detection of servers that are out of line from a patching standpoint is something that you can typically automate very well. Again, in most environments, we see the actual patching process is slow because of the concern that that you're going to break something if you apply a patch. Again, in really mature environments where they're doing the type of chaos engineering, maybe you can roll some subset of servers forward, see if anything breaks. That's an aspirational level to get to for a lot of the organizations that we work with, right? So you should be able to detect very quickly if servers are out of date, but it's probably going to take, the patching process may be more automated. And again, from an operational management standpoint, your data protection, these again, you're not going to see a lot of automation around these, or making the decision to to decommission servers or decommission applications is also something, again, that is an organizational process that is not tied to CI/CD or any sort of automation. Okay, so we've gone through the entire OWASP SAM and kind of looked at like what parts of this is it reasonable to automate, either broadly or in the context of a CI/CD pipeline, and what are the things that you shouldn't expect to automate. And so, like when I look back across all of this, I've got a couple conclusions that I've drawn out of it. What can go into a pipeline? The linting fast static analysis tools with limited rules, dynamic testing if you can target it. I asked if you if you can generate meaningful traffic so that the IAST engine gets the data that it needs. Software composition analysis if you want. Like those are the types of things configured in that way that it is very reasonable to expect to get into a pipeline. But what doesn't go into a pipeline, right? Like what likely has to be done outside of a pipeline. And so that's when we look at that kind of full commercial grade or industrial grade static analysis, where you're doing data flow, control flow across different components. Again, not realistic in a lot of cases to run inside of a pipeline time budget. Your full dynamic testing, dynamic targeted fuzzing of web applications, your manual code review, your penetration testing, your threat modeling, right? These are all really important practices for a comprehensive software security assurance program, but where it's not reasonable to expect to fit them into a CI/CD pipeline, right? And so again, to understand, there are, for as advanced or as cool as you might be able to make what you're doing in the CI/CD pipeline, these are critical activities that still have to be done that are going to be done outside of that pipeline. What else has to be done outside? All the other stuff, strategy, policy, training, architecture, security requirements. Those are all things that are done largely outside of these pipelines, or maybe automation supported, but where automation is not sufficient to, again, where the task is not automated, you are supported in accomplishing that task by automating portions of it. And so, as I said, like shifting left is awesome. And like nothing, I don't want anything that I've said here today to be construed as being, negative on shifting left or saying that that is not valuable. But what we have seen is too much focus on that. And that's only one aspect of a far more complicated landscape, right? So when you think of testing, I think it's important to think of it from a coverage standpoint, right? What are the different classes of vulnerabilities that you're concerned about finding in this application, right? What are your different detection approaches? Static, dynamic, manual pen testing, manual code review, and what is the quality of each of those approaches, right? So you very well can get some level of testing that is very valuable in a CI/CD pipeline. But again, I think it's important to take a step back from that and understand more broadly, where are my testing activities in the CI/CD pipeline? Maybe am I doing things in the pipeline that I shouldn't be because they're going to be running too slow or producing results that aren't of the quality that we need, right? What things might need to be moved out of the pipeline, and am I undertaking these activities outside of the pipeline to get that sufficient level of coverage? And then for everything else, again, you want to look at this from a programmatic standpoint, not being specifically focused on the CI/CD pipeline. From that now, just open things up for questions. Again, I'm pretty easy to find. I'm Daniel Cornell on Twitter. My new email is daniel.cornell@coalfire.com. Happy to answer any questions that you all might have from anything that we went through. That's a lot of slides, and I apologize if for anyone who's not a native English speaker. I apologize for I probably speak faster than is convenient or is helpful. So I apologize for that. Again, happy to drill deeper, answer any questions that you all might have.
Yeah, this is the most comprehensive deconstruction of a CI/CD pipeline from a security aspect I've seen, and it's most of the things some of the things I've been Googling while you talked. It was very interesting. The first thing is I've also seen recently is how do you motivate developers to participate in the security champions thing that most companies seem to be doing right now? And how can you, like, have you seen any approaches where you can push them to improve the CI/CD pipeline because they see it and they have most of the times they have complaints, speed wise, and some false positives and stuff like that? How have you, like, I've seen it in a couple of times, and it's like a formal thing, but it doesn't work very well because developers are not into it a lot.
No, great question. So to talk first about the security champions, how do you motivate developers? And again, I encourage people to take a look at that security champions webinar where we go into like a lot more detail and look at some of the research that John Dixon has done, talking to a lot of folks. But so for certain developers that are interested in security, right? Which is not going to be all developers, but ones that have a particular interest in that. I mean, those are the types of folks that you can identify and you can motivate them by providing them. I mean, that can be an excellent way for career advancement. To have an expertise in security. That is a way that certain developers choose to differentiate themselves. And they can be provided with additional training and things of that nature. Where these security champions programs, or as you roll those out, that can help you to identify where are the developers that are most interested in in security, and then they get perks from that. We've also seen the Adobe folks had their they had a very elaborate system of training, and like a belt system, like it was a martial art for developers to advance. That is really great in an organization that large, maybe out of the not within the grasp of smaller organizations. But one of the things we found is, again, like, how do you motivate developers? It's you can provide them with additional training, additional career prospects. That has been valuable for people that have self-identified as being interested in security. We've seen that be very successful. When we look at, like, how do you push developers to improve security in CI/CD pipelines? Again, the thing that hurts security teams is when they drop security tools into the pipe, when they try to go to a high level of maturity and automation directly, right? And so if you're like putting a tool into the pipeline without understanding the time budget that the development team is willing to allocate for security, that's going to be a problem, right? If you're running it with the default rule set rather than a tuned rule set, that's going to create problems. If you're trying to push for automation of defect creation and things like that, just straight out of the gate, that creates problems, because what you do is you bring this tool, it runs too long, it generates a bunch of results that no one cares about and breaks the build and pushes a bunch of stuff into Jira, and all of a sudden, like the development team has every excuse to go up to their management and say, when we invited security in, they created a giant problem, right? But if you work with the development team and say, hey, we're going to run this tool, but we're going to run it in an asynchronous manner, right? So it can run and finish, and it doesn't have to be within your pipeline, right? And we're going to curate the results before we show them to you, right? That creates less resistance typically from development teams, because maybe the CI/CD pipeline again is initiating the tooling, but but you don't have to worry about the time because you're not waiting for the end of the tool for that. You're not impacting it, right? And so you can go from a situation where you've got full tool runs, then you skinny the results up that you're that are coming out of the tool to make sure those are the valuable ones. And then you can look at saying, oh, well, let's make a pass or fail decision based on these, right? Or let's create defects based on these, right? And so, you want to incrementally, from a security standpoint, you want to incrementally come in and show value, as opposed to just, deploying, well, here's a tool and it's going to run as long as it's going to run, and you're going to get all the results from the other, at the end, and trying to automate too much stuff, right? And so, I think it's important to understand, why are you doing, what's the value of having the tool in the pipeline? And if the value of having the tool in the pipeline is to say you have a tool in the pipeline, like that's probably not the best approach. But if instead you're saying, well, hey, we want to identify cross-site scripting and SQL injections so that those don't ever make it into a build, like, oh, okay, cool, we can tune the rule set to do that. Right, that's a different reason that you might be incorporating this, and so like that's where we've seen folks be more successful, right? Is to take an incremental and a thoughtful and planful. I don't know if planful is actually a real world word in English, but one of our engineers uses it a lot, and I like it. But if you take a more thoughtful and planful approach, like we've seen that reduce the resistance of the DevOps team to incorporating security. Because you're bringing value as opposed to, just kind of creating chaos by the inclusion of security.
Yeah, that kind of makes a lot of sense, because what I've seen is developers complaining, okay, Tuesday I come to work and there's this new tool that is doing something, and I expected something to happen in 2 minutes because yesterday it happened in 2 minutes, and today is some new scanner on my machine, or some step in the build process that was nobody informed me and was done by these shadow people that you rarely see. They live on another floor of the building and they don't see anything. What do you think about doing some checks before committing or pushing to a centralized place, like doing it on a developer's machine?
Yeah, I like that. I like that as well for developers that are in a position to consume those results, right? And that's again a challenge with, I think, the way that a lot of security tools have been like rolled out and sold in the past, where especially like static analysis tools, like everybody tried to be the static analysis tool that found the most stuff, right? And that's how all the vendors like competed with one another. We find the most stuff. Well, as it turns out, as soon as you try to operationalize that technology, you don't want to find the most stuff. You need to find the important stuff, right?
Exactly.
And so I think a whole generation of static analysis rollouts were in bad shape from the outset, because the tool was tuned and used in a bad way. Right. But, if you see some of these, again, kind of lighter weight static analysis tools that are integrated with IDEs, if you have developers that are, and again, this comes back to security champions, where if a developer can understand looking at the results coming out of a SEMGREP or something like that, so that they can make a determination if, yeah, this is a problem or not. With a little bit of training, you can, like, I think that's great to say, like, hey, in the IDE, we're going to identify, we're going to lint or spell check. I mean, there's both open source and commercial tools that are trying to fill this niche, and I think that's great. I mean, like, that's even better if you can have the developer identify, like, oh, I've got a coding flaw here. I want to fix that before I even check it into a repository. Like, that's a huge win, because those never even, even if you're not doing continuous, deployment from your pipelines, that bad code never even made it into the repository, right? Which is a huge win. So again, love seeing stuff like that. But my caution would be, when you put security tools in the hands of developers, they need to have sufficient training or context that they can use that tool. And again, we've seen a lot of bad rollouts of security tools where you're giving very sophisticated tools. I mean, if you look at, again, the big commercial static analysis engines, they're going to find tons of stuff, right? And there are situations, again, like from a consulting standpoint, like I want to know all the stuff, and then I want to like shrink that result set down to what we ultimately hand over to the client. But if I'm a developer, I've probably got a different use case. I don't want to know all the stuff. I want to know the important stuff that we have high confidence in, right? And I'm going to depend on someone else, the security team or something else, to catch those more subtle bugs. Because again, the developer, you can't expect every developer to be a security expert. Again, earlier in my career, I believed that was the answer to the problem. I no longer believe that, right? Like every developer isn't going to be a security expert. So when you put security tools in the hands of developers, you need to have realistic expectations and proper training so that they can get the desired outcome, so they can help accomplish your desired outcome by providing the developers with that tool.
Okay, another question is, you mentioned the application security verification standard, and they have a version for mobile apps now, the MASVS, or whatever the abbreviation is. What do you think about it? I've seen developers, when we show it to developers, and they don't like, it's a long and tedious document, but if you want to test an application and start from like a senior developer position or software architect position, you can go through it and then test an application. But I've never seen it done in real life.
Right. And so I think that's an important thing to, if you look at who the intended consumer of the ASVS or the MASVS is, like those are targeted towards security professionals, right? And security testers, so that they know, and we use ASVS and MASVS as the template. We've, of course, got some custom extensions and whatnot, but I mean, we use that as the core for our app testing, looking at different levels of depth of testing. and that's great for a security tester. That's not necessarily great guidance for a developer. Maybe for a senior architect, it's reasonable to be able to walk through with that architect to say like, hey, here's the concerns and how are you addressing these? If I look at OWASP resources, I think that the cheat sheets series that I think Jim Manico has been hugely influential in that, and is, I think, kind of broadly the maintainer of it. Those are documents that are much more valuable for developers because you can provide them with, hey, you're writing an API. Here's an API security cheat sheet that's a 3 to 5 page document or something, maybe even shorter. That's going to be kind of this like bite-sized consumable, just like I talked about with training. If you, for the average developer, you need to be able to say, oh, you're about to start undertaking this type of risky security coding. Like here's a targeted, checklist or something very small that you can consume that will ready you for what you're doing next. Versus again, the like ASVS or MASVS, which are great documents, but are, I mean, if you give that to a developer, there's like their eyes will roll back in their head, like, there's so many things that can go wrong. I can't possibly, this is not consumable for me in a way that is going to help me do my job.
Exactly. What we've been telling, like if you talk to a developer and tell them, yeah, this is what a pen tester usually does, goes through a checklist, and if you go through the checklist, you can look better in an eventual pen test, and you can catch stuff that they will catch if you don't fix it. You mentioned the OWASP dependency check. Have you seen, like, I've tried to popularize it here as a chapter leader. Even before that, I really like the tool, but I haven't seen anyone use it. Like most companies, they use the commercial tools.
Yeah, and I mean, as with all, in any class of tool, you're going to find the commercial vendors have certain priorities and certain ways that they roll things out versus the open source tools. The resources available are going to be different. And so, for a, for an organization, if you have one of the big, commercial tools, like fantastic. I mean, take tremendous advantage of it. I've used dependency check a bunch. There's certain areas where it finds, false positives on a fairly consistent basis, and you've got to understand that and clean the results up and whatnot. But if you're an organization where, and thankfully, like in the commercial tool space, I think we found new entrants in that space that are somewhere between here's dependency check that is freely available, and here is your 6-figure plus implementation commercial tool. There's now, I think, some more folks in that middle ground space, or freemium models and stuff like that. So I think we've seen more entrants into the software composition analysis space that are appropriate for organizations of different size and different budgets. But again, if your organization hasn't looked at software composition analysis, dependency check is a great way to start taking a look at that and understand, and to look to see like, oh, now we really see all the stuff that is being pulled in, not just our first line dependencies, but the but the transitive dependencies and stuff like that. And like, here's a bunch of results. Okay, let's clean those out. Again, if you're an organization that has one of the kind of big box software composition analysis tools, that's great. If you're an organization where you're still working from a maturity standpoint, still working from a budget standpoint, for a security engineer, that is a dependency check is a tool that is a totally legitimate starting point to use. So it's kind of a question of the resources you have, what your current tool toolbox looks like, and where your organization is in the cycle of maturity.
Yeah, thanks. Also on the same page is, have you seen corporations kind of contribute to like open source tools? Like I've never seen a company, local company here, that, for example, contributes with data for the OWASP top 10. And I know it's hard to scrub to anonymize the data, but how can that be incentivized?
Yeah, no, and that's a great question. And I think and this is just a challenge with with open source. So with OWASP and OWASP tools specifically, with open source in general, is creating that ecosystem where organizations can give in order to where they get sufficient value from giving, and how do they get that value. And so when you look at firms that are in a position to contribute like vulnerability data to the OWASP top 10, it's going to be the like platform scanning vendors and the and consulting companies that are sufficiently motivated like to get their logo on the on the OWASP top 10 report. Those are going to be the organizations that are probably going to derive sufficient value from participating in that, such that it makes sense for them to go through that process of anonymizing the data to make it available. And that's also, I think, a challenge, and where I was actually in a Twitter conversation just with Manico and some other folks, just looking at like, what are the economic incentives? And the challenge there is, I think to the community, there is even more value. If I look at a financial services and insurance organization, something like that, I think that they have a perspective that is potentially even greater value to the OWASP ecosystem. The challenge being, what value do they get, like for taking the risk of participating and the resources that go into participating? Do they get sufficient value in return? And I think that those incentives like aren't as well fleshed out as they could be, and even in cases where those incentives might be sufficient, I don't know if they get communicated sufficiently. And so I think that I don't have any real big thoughts in that area, other than to say, I think that having participated in OWASP as a vendor and understanding like why that made sense for Denham Group, and then rolling into Coalfire, I think that there's probably a conversation to be had around like, how do we create better incentives to get organizations to contribute back, as opposed to it being something where individual contributors do it for like career advancement reasons, or because of the passion they have, or something like that.
Yeah, thanks. I kind of, because companies here are kind of, they understand the value of doing stuff for the community and the open source organizations, so that can be kind of improved upon, because marketing wise and PR wise, it's a good move, and everyone knows what the OWASP is. Mm-hmm. You mentioned Chef, Puppet, and Terraform, but you don't ever mention Ansible.
Oh, right. Yeah, no, that's just just a not an intentional snub of Ansible. It's just again the tools that I'm most familiar with. But yeah, Ansible also would be in that ecosystem of these, like how do I manage my infrastructure as code and get that deployed into these cloud environments. So yeah, Ansible also totally legitimate entrant into that space, just limited by some of the experience that I have with the different tools.
No, it's kind of like a joke, because we usually use here a lot of Ansible, and I kind of wanted to ask why not, but it's just the tools that you use. I don't see any other people asking questions, and the chat is empty. So I hope you get better with your recovery from COVID. That's what you said, right? I wasn't exactly listening, but and you said you're
on the tail end of that. So I'm almost totally better. Supposed to be done with quarantine today. So
okay, so I really hope it's done in as quickly as possible, and I really appreciate you doing a session on your birthday.
Yeah, no, but thank you all very much. I appreciate everybody taking the time to come out and attend this and to ask questions and things like that. And I'll get you guys a copy of the slides.
Yeah, I'll send you an email, because we published them, and this is part of the whole package with the YouTube video being published from the Zoom recording and everything. So yeah, I really appreciate it. So expect an invitation soon again, because I really enjoyed this talk.
Excellent. Thank you all very much.
You have to end the meeting.
Thank you, Dan.
Because you're the host. Yeah.
Okay. I'll stop the share. Recording is going. Do I have to stop the recording?
No, it will stop automatically when you close the whole session.
Very good.
You're the host. Have a nice day. Yeah.
Take
Bye.
care.